In this question, we're given the angle of inclination is 30 degrees. And what else are we given? That's it. This mass is at rest. And there's friction, and we need to find the coefficient of static friction. So static friction is mu s, as opposed to mu k for kinetic friction. And we also have gravity. Let's define gravity as negative. So we're going to follow the conventions of up and to the right as positive, meaning down and to the left is negative. First thing to do to approach this question is to draw the free body diagram. So here we have our normal force, and our friction force is opposing the direction that the motion would be, and our force due to gravity. And the trick to this question is to create components out of the force of gravity in order to have forces which are parallel to the normal force and the friction force. So when we make components with the force of gravity, this is how we do it. We make a right angle triangle, so we can use trig later. And you can see now we have this component of the force due to gravity, let's call it the force due to gravity in the y direction, is opposite the normal force. And now we have another force, Fgx, parallel to the force due to friction. And that allows us to come up with some equations. So we kind of have our axis a bit skewed here. We kind of have our y-axis like this, and our x-axis is kind of like this. Let's look at the net force in each of these. So what would the net force in the y direction be? So we would add the forces that are parallel in the y direction. So we have Fgy and Fn. Next, we can think about the forces in the x direction. So the net in the x direction is based on the force due to friction parallel to the Fgx. So we'll add those to start. So this is in the x direction, and the force of friction is also parallel to that. So what do we do next? Well, there's three things we can do. We can look at what F net would be. We could substitute for the force of friction. And we can also substitute for the components in the x and the y direction. So it doesn't really matter which we do first. Let's just talk about F net first. So think about whether the crate is moving at all. It's not, it's at rest. Since it's at rest, there's no net force acting on it. Otherwise it would be moving somewhere. There are many forces acting on it, but they're netting out or canceling out to zero. So we know the net force in the y direction is zero, because it's not moving anywhere up and down in that plane. And we know the net force in the x direction is zero, because it's stuck to the face of the plane. Now let's think about what Fgy and Fgx are. This is actually fairly important. We can translate this 30-degree angle. The angle of inclination always goes here. And I could show why. I actually have another video on that already. So to save some time, we'll just assume that we understand that. And that allows us to rewrite the components in terms of Fg and the angle 30 degrees. So you remember that sine of some angle theta is opposite over hypotenuse, and the cos of some angle theta is adjacent over hypotenuse. And that rearranging for the opposite and the adjacent, here we have the opposite is Fgx, and the adjacent is Fgy. Rearranging for those, we should be able to write in terms of Fg. So we have Fgy as the hypotenuse times the cos of theta, which is 30 degrees. And Fgx is opposite from the angle, so that's Fg times the sine of 30 degrees. So now we can substitute for that in our equation. So Fgy is Fg times the cos of 30, and Fgx is Fg times the sine of 30. Next, we can write everything else. We have the normal force, Fn, and we have the force of friction. We have an equation for that. We have the force of friction equals, for static friction, mu s times the normal force. So we'll write that in there, just barely fitting. So to solve for mu s, which is the whole point of this, we can see that we have two equations and some unknowns. What we could do is we could substitute for the normal force, and so we would rearrange for the normal force and substitute that into our equation 2, and then we could isolate. So isolating for the normal force, Fn equals the negative of this, and we could put that into our second equation right here. So let's do that. So we have our mu s times the normal force. We're substituting it in, make sure we multiply. And now we can isolate for mu s. So let's do that. Rearrange. Move this to the other side so it becomes negative. And cross divide by this. So I'm kind of doing a few steps at once here, but I think most people understand order of operations and rearranging. Now we have one term on the top and one term on the bottom. We can cancel FG. Negatives also cancel. So we have the sine of 30 divided by the cos of 30. If you remember identities, some people have done identities already, that equals the tan of 30. But anyways, if you just want to divide sine of 30 by the cos of 30, you'd get 0.577, which would round to 0.58. And remember, coefficients of friction are unitless, so that's it.